Hello everyone, welcome to Scholar Lab. Our simulations can transform your teaching approach, making lessons much more interactive and captivating for your students. Scholar Lab is a distinctive virtual laboratory that brings intricate STEM concepts to life through engaging simulations. This tool is crafted to aid students in comprehending and applying scientific principles in practical situations. Welcome to the exciting world of centripetal force. Our main objective today is to dive deep into the concept of centripetal force and understand the direction in which it acts on a body moving in a circular motion. To make things even more engaging, we are using a real-life example, a merry-go-round. So, let's jump in and explore what keeps a person stable or causes them to fly off due to the effects of static friction and centripetal force. Let me open centripetal force simulation for you. First, picture yourself on a spinning merry-go-round. You're free to view the ground in 360-degree angle by click, hold and drag your mouse cursor. Here's why the things are getting interesting. As I'm moving the cursor slightly, you'll see the arrows representing the forces acting on the person. One of the most important force is that centripetal force, which always points towards the center of the merry-go-round, the red one. This force keeps you from being flung outward. Now let's add some more dimensions. I'm going to activate static friction and centripetal force graphs. By clicking on this toggle formula button, the formula of centripetal force and static friction force will appear in the bottom. Here's the fun part. You can change the mass of the person and the velocity of the merry-go-round using these two sliders. Let us check. If I'm increasing the mass, the centripetal force and the static friction force is getting increased on the graph. Similarly, if I'm increasing the velocity, the centripetal force will get increased. Let's check it out. The more the speed increases, the harder the merry-go-round pulls you inward. When you increase the speed, the kinetic energy also increases, and with that, the centripetal force also increasing. You will notice that faster the merry-go sprints, the more the work friction has to do prevent you from flying off. Now notice how as the speed increases, the static friction between the person and the surface of the merry-go-round also works to keep them in place. For showing it in very slow motion, I am clicking on this button to make the movement in slow motion. Now I'm going to increase the velocity and check what will happen to the person standing on the merry-go-round. If the speed is increased too much, the friction may not be strong enough to causing the person to fly off. As a conclusion, the more the speed increases, the harder the merry-go-round pulls you inward, and the larger the mass and the greater the force required to maintain the circular path. I request you to try increasing the speed using this velocity slider and adjusting the mass of the person using the slider, and also feel free to change the radius of the circle. this interactive tool, you will not only understand the underlying concepts but also feel the force in action. Let's explore how this invisible force shape our experience of circular motion. It is an exciting journey in physics filled with experiment that will thrill your mind. Thanks for watching.